that's what it takes, huh? That is our curriculum, yes. Or that is our curriculum resource, yes. Alright, adding rational numbers. We've talked about rational numbers. What is a rational number? We talked about them yesterday. Yes. 7 is a rational number? Yes. It's basically any number that you can write down. My husband last night asked me, so what is a rational number? And so it's like, it's basically any number that you can write on paper. You guys, pre-AP, they have to deal with irrational numbers. So rational numbers, these are your fractions and decimals. They can be positive or negative. Fractions or decimals, positive, negative, whole numbers, integers, all of those are rational numbers. We'll start with the easier one. When we add decimals, same rules as when you're adding integers, as far as if they're on the same team, you add them together. If they're different teams, you subtract. Or I like to say, if they have the same sign, you find the sum, which means add. If they have a different sign, you find the difference, which means subtract. So same sign, sum, different signs, difference. For example, if you have, and you have to line up the decimals. That's the biggest thing. Line up the decimals. That's very important. So if you had negative 2.5 plus 6, same sign or different sign? Different signs. So we need to find the difference between 6 and 2.6. What else do I need to do? So I'm going to subtract 6. Do I line the 6 up with the 2 or the 6 up with the 6? 6 up with the 2. So that's going to be 6.0, and that's 2.6. And I'm going to subtract those two. So that's 3.4. Yes. Which one's bigger? Positive team or negative team? The positive team is the bigger team, so I have a positive answer. There's another way to do it that's a nice visual. We're going to do an open number line. Here's 0. My first number tells me what to do first. So I need to go to the left 2.6. I need to go to the left, negative 2.6. Then the second number tells me what to do next. I need to go up 6. So I need to turn it around and go up 6. Now, from here to here was 2.6. From 2.6, how much more do I need to get to 6? No, I totally paused it. I'm going to yell at somebody on camera. So it's this is 2.6. And then this is 3.4. So if you need a visual, this helps. If you're good with the numbers, this is good. Okay? So this is decimals. Now for the fraction part. First rule of fractions. If the question is a fraction, your answer needs to be a fraction. Let's just say that. If a question is a fraction, then your answer needs to be fractions. It's like if someone asks you a question in Spanish and you answer in English, you're speaking two different languages. If you ask in Spanish, answer in Spanish. If you ask in English, answer in English. If I ask you a question in fractions, tell me in fractions. Don't change them to decimals. It doesn't always compute well. So just like what, 4th, 5th grade when y'all learned about adding fractions? Somewhere in there? That's okay. The biggest thing to know is you have to have a common denominator. I like to think of fractions as puzzle pieces. And if I have big puzzle pieces like from a little kindergartner puzzle, and then little puzzle pieces like from a 1,000-piece jigsaw, those two puzzle pieces don't go together. I need pieces that are the same size before I start adding and subtracting those pieces. I can't take big jumbo kindergarten puzzle pieces and put them with jigsaw pieces. That doesn't work. Yes? Do you have a question? Or you just, oh, never mind. So, common denominators first. So let's take 1/2 plus -3/4. So my first step, common denominator. What is my denominator?
4.
Okay, so 3/4 is going to stay the same. That's going to be -3/4. What do I need to do to 1/2 so that there is a 4 on the bottom? Not make it a 1. We're going to multiply it by what? 2, which is going to give me a 4 on the bottom. So I have to do times 2 times 2. Double the top, double the bottom. So 1 times 2 is, and 2 times 2 is,
Why is it 2?
because 1/2 is 2/4. We just have to take our big puzzle piece and cut it into small pieces so that they'll fit with the little pieces. You can't take your 1/2 puzzle piece and work with your 3/4 puzzle piece. They don't work. So if you have a pie, let me see if I can figure it out a different way. You have these two things. One is cut into halves that look like this. One is cut into fourths that looks like that. I have 1 of these and 3 of these. I need to put them together. I can't take this big piece and fit it with this little missing piece. So I have to cut this piece into fourths to match these pieces. Then I can work together. Yes, so here's where I double it.
What can you divide 2 by to make it 4?
Yes. So 2/4 is the same as 1/2. It's just in a different, like you're just saying it differently. Now we follow our integer rules with our numerators. Follow integer rules with numerators only. W/ is with numerators only. So I'm only going to look at these two numbers. What is 2 plus -3? Say it again. -1. Because if you have 2 on the plus team and 3 on the negative team, and they run directly at each other, these 2 cancel out and you have 1 left on this team. While these 2 fell out. So -1. And then how big are the pieces I'm dealing with? They're fourths. So the bottom number stays the same. Keep the numerator. And then with all fractions, reduce if you can, and that's it. Ooh, that's brown. Don't want to use brown. You thought you what? Oh, okay. We can't reduce -1/4, so that's the end.